So in this tutorial, I'll be explaining how to find the area under the normal curve for the following. Recall that if you have the normal curve here, the mean is going to be a specific number given, unlike the standard normal. The standard normal will have the mean to be 0 and will have the sigma to be 1. This was done in the previous video. But for the normal curve, here the sigma is also going to be a number probably given to you. Okay, so by doing this, then we can use the probability that our x, which is going to be our random variable in this case, is in an interval. In an interval. To do this now, so we can use the normal CDF from the calculator. So we can use the normal CDF, lower bound, the upper bound, the mean, and the sigma. Okay, so now we have this example and we want to implement these functions. The example says that the weight of adult women in a certain city are approximately normally distributed. This is very important. Here you've been given the condition that the weight, which is your random variable, the weight of the adult women, that is going to represent our x. Okay? So we've been told that it is normally distributed. That is, we can easily use the normal CDF. So with a mean of 145 pounds, here we have our mean given to us as 145. And the standard deviation of 18 pounds. And here we have the sigma already given to us as 18 pounds. Now the question is, what is the probability? What is the probability that a randomly selected woman height weighs to the weight of the woman, which is the x? This is our random variable. More than, you can see, more than, this means greater than 170. So this is how you break down the question. Now, to use the normal CDF approach, there's a need for us to draw the normality curve. Okay, the normal curve. So here we have this normal curve. Don't forget, our random variable is x. And here we have the center, which is the mean, at the center, which is equal to 145. Okay? We have the mean as the center, which is equal to 145. Now, the question is, what is the probability that a woman weighs 170? So the random variable of 170 is going to be here. Okay? So here we have 170, which is going to be to the right. So here we have more than, which means we're going to the right. Okay, we're going to the right. Now, from here, when you have this going to the height, we have the normal CDF. The lower bound is going to be the starting point, which is this. So our lower bound is going to be 170. And the upper bound is going to be infinity. Recall from the previous video, I told you the random variable is going to be from negative infinity to positive infinity. So going to the right, we are going to the positive infinity. So here we have positive infinity from the calculator can be represented as 1e99, comma, the mean. Okay, don't forget we are using this formula. The mean given is 145. And our sigma is what? Is 18. So this is what we got. Now, what is the probability? Now, coming down to this calculator, in the previous video, I told you we have the second function, the distribution. Then you can come to number 2, which is the normal CDF. Click on that. The lower bound is 170. And the upper bound is 1e99. And to get the e, you click on the second function and you click on this e99. The mean is no longer going to be 0 in the case of standard normal. This is normal curve. So for the mean, we have 145. And for the sigma, here we have 18. So by pasting this, the probability is going to be 0.0824. So this is the probability that the woman is going to weigh this. Or you can say that this is 8.24. Actually, it's a little bit low. Okay, that you have the woman, based on the information given to you, that the probability is going to be more than 170. Now let's look at another example we have. In this second example, it says, what percentage of women weigh less than 120 pounds? It's still the same thing as calculating the probability that the women weigh less than 120 pounds. Now, drawing the normal curve as usual here. Okay, so the random variable still remain as x. This is our center, this is your mean, and 120 is going to be on this side, which is not up to 145. So here we have the 120 here. Okay, now, so here we're looking at the area to the left. Why? Because we have less than. So we are considering the area to the left, which starts from negative infinity. Now, using the normal CDF approach, so here we have the normal CDF. The lower bound is going to be the negative infinity, which is negative 1e99. And the upper bound is going to be 120. The mean is going to be 145 as previously used, and sigma is still going to be 18. Now, using the calculator, we press the second function, the distribution. Coming to the normal CDF, the lower bound is now going to be negative infinity. And I told you don't use this negative sign. Instead, use this negative sign. So we have negative 1e second and base 99. And for the upper bound, we have 120. 120. And for the mean, we have the same thing, sigma, the same thing. Then we can paste. So here we have 0.0824. Now, looking at this, you can see that we have the same thing here. And just like in the previous video, I was asking, why do we have the same thing? Now, I mean, we are having the same value on this side, just like we have for this side also. This is something I want you to think about and put the reason why in the comment section. Don't forget that if you look at the distance from here, from the center here, from 145 to 170, we have the distance of 25. 25. And from 120 to 140, you also have the distance of 25. So if you think about this very carefully, there's something we call the law of symmetry. A normal curve is symmetrical. So you have to think about that. So you can put your discussion in the comment section about what you think about it. But just think about the symmetric property. Okay? Yeah, let's go to question C. The question C says, find the 90th percentile of the weight of adults given. Now here I want you to think very carefully here. In the previous two examples we've done, here we have the x value given to us. What we did is just to get a corresponding probability or the area under the curve. But for this here, we have the area under the curve given to you. For you to understand this, there's a need for me to draw the normal curve, that you understand what I'm trying to say. So we have a random variable to the x. We have our mean as usual. So the 90th percentile should be very close to this place. Okay? The 90th percentile should be very close to this place. That is, the area under this curve from the beginning to this is, we have the 90th, we have your P 0.09. Okay, so what we want to do is to get the x value. We want to get the weight when you have your 90th percentile. Okay, so what is going to be this exact value here? The exact value here. Okay, to give 90th percentile. So by doing that here, we use something we call the inverse norm. The inverse norm. The inverse norm is used when the area under the curve is given and you want to get the exact x value. This can be done for the z curve, for the z value too. Over here, we are working on the normal distribution. So here we do this inverse norm, area to the left. Okay, we consider the area to the left. We consider the comma mu, comma sigma. And if you look at the area to the left of this, here we have 0.9. Because to the left up to this place is 0.9. Comma mu, which is 1.5. Comma sigma, which is 18. So let's do this. We have second function distribution, and we go to number 3, which is the inverse norm. So the area to the left is 0.9. The mean is 145, and sigma is 18. So if you paste this, then we have 168.07. Yeah, let's put it that way, approximately. So that means for 90th percentile of the entire data set, they are going to weigh what? 168.07. So here, if you look at the part B, it says a fitness club wants to create a special program for the lightest 5% of the women. What is the maximum weight a woman can have to qualify for this program? If you look at this question carefully, it's saying that the maximum, okay, the lightest 5%. That means the remaining 95% are not needed. So the lightest 5% of the population of women, what is the maximum weight? So I want you to use the same approach. In this case also, we are using the inverse norm. Okay? So I want you to do this and put it outside the comment section. See you next time. Bye.